Okay, so we are doing CP2. This is lesson 1. I just fixed one of the pictures. Yes, they are. Okay, so by the end of this lesson, you will be able to define a circle. It's not particularly exciting. A radius and a diameter. So I'll give you a little Latin lesson over here. We're going to name minor arcs, semicircles, and major arcs. Now that may be new for you. You should know what a circle is, a radius, and diameter. That's old material. We're going to talk about central angles today and understand the relationship to arc measure. And recognize and define chords, tangents, and secants. And since your notability doesn't work, iPad should be down. There's only like a couple people. Does it? Maybe they're getting it fixed. But what's happening is it's deleting. Okay. The radius of a circle is the segment that joins the center of the circle to any point on the circle. You okay? Yes, and what's true about all the radii in a plural radius is radii. What's true about all the radii in a circle? They are what? They're congruent. Okay? So we need to know what a radius is. Hey guys, we need to know what a circle is. Hey, Curran? Circle is the set of points that are from the same distance from a middle point or a center point. The center point is not part of the circle. So the circle is just this outer edge here. This is the center of the circle, but it's not part of the circle. And the distance, all these distances are equal. Okay, so if PA is 5 centimeters, then how big is PB? 5. I don't think we're going to worry too much about units in this unit. Okay, a diameter. All this should be old material for you. Diameter is a segment joining the center of the circle with any 2 points on a circle. It's got to go through the center. Okay, Zach? It's a chord, and we're going to get to chords. The chord should be defined first. But a chord is any segment joining 2 points on a circle. In particular, the diameter is the longest chord in the circle. Now, I don't like to write the word circle, and most math people don't like to do it either. So they draw a little circle, put a little dot in there, and that represents a circle. That's how we name circles, too. So this is circle P. Okay, that's all old stuff, right? Not particularly exciting. Okay, now, you may not have called congruent circles. You may not have talked about congruent circles, but these are circles if they have the same radius. So, since OA is congruent to BP, I don't have to write the word circle. I can do this little symbol. Circle P is congruent to circle O. Okay, TJ? Should be taking some notes on the note packet I killed a few trees for. Okay. Okay. Shh. They're still alive. Okay, guys. Guys. Cole, Zach, let's get this done so you have work time. Then you probably won't have homework over the weekend. Okay, concentric circles, you've seen them all the time. If you throw a rock into the lake or into a pool of water, you see the ripples that go out and you get concentric circles. They have the same center. They'll have different radii though. Again. Yeah, so don't use notability. I gave you handouts. Until it gets fixed, we'll just work it. They have different radii. They have the same center. The same center if they're concentric. No, it says
Radius is plural.
congruent circles have the same radii. That's the plural of radius. It comes from the Latin. 60% of the English language is from Latin. So having studied Latin for 5 years helped me a lot with the SAT. Okay, we ready? Okay, this is what might be new. Arc of a circle. 2 points on the circle. Any 2 points. I could take this one. Okay, guys? That is an arc. Now, how do I write arc? I take the 2 points, BC, and I draw a little arc symbol above it. Okay, so the symbols are going to be important. I know a lot of you in the first chapter didn't realize that that was so important, but it is. Because this tells me I'm not talking about segment BC. That would be segment BC. I can tell what we're talking about. Okay, we're talking about an arc. A semicircle is an arc. I actually get that to work. Whose endpoints are the endpoints of the diameter. So here is a semicircle. Good. Use 3 points to name a semicircle. So I need another point here. I think I might have missed that. I fixed the circle. If you look at your handout, it's a little bit squished. I didn't like that. So this is a semicircle. E, D, C. We go around the circle. Okay, Zach? Put that away, please. Nope. I need 3 points. Where E and, guys, where E and C are the endpoints of the diameter. And then any point, D could be any point in between there. Yes, they've named the other semicircle, which is this one, CBE or EBC, doesn't matter. But your endpoints of your diameter are going to be on the outer edge. So CBE. And honestly, it's an arc. So I could put an arc there. It's a semicircle. Okay, a minor arc. Because we're going to find relationships between arcs. Sorry, I missed major arc. Major arc is an arc that's larger than a semicircle. So if I want to talk about, let's see, this arc right here, from E all the way around here to B. Guys, do you need to sit someplace else? What's the name of this? This is a major arc. It's E, D, B. Or you could name it E, C, B. There's more than one answer to name a major arc. You take the endpoints of the arc, those are the outer letters, and then you take any letter in between. But you're going to need, that's right, a minor arc is smaller than a semicircle. And guess what? We only need 2 letters here, where we needed 3 letters for the major arc. So when you see 3 letters, you know it's going to be more than half of a circle. Minor arcs are going to be 2 letters. So can you name a minor arc here? B, C. B to D looks like less than half of a semicircle. And what about B to E? Do we have A to D also? Where's A?
I think it's A.
Oh, I thought I kept the same, but anyway. Okay, so we have EB. There's lots of them. Okay, so we did all that. Okay, Cole, question? Okay, we named the semicircle, we named the arc, the major arc and the minor arc. A little more. Ready? Now, we have these things called central angles. We are also going to have inscribed angles. And an inscribed angle looks like this. Okay, so that I want you to see that there's other kinds of angles. If the vertex of my angle is at the center, it's a central angle. So the vertex of the angle is at the center of the circle. And we have an interesting situation here. If this is my central angle, the measure of this minor arc equals the measure of the central angle. Okay, Curran? So if this is 50 degrees, then the measure of this arc, which we write M arc BC, equals 50 degrees. This is not going to be true on that inscribed angle. It's going to be a different relationship. Yeah, but that measure of this arc. So the measure of angle BOC equals the measure of the arc BC. So you know we're going to be doing some problems where I'm going to give you arc measures or angle measures, and you're going to find the other ones. Okay, so if BC is a minor arc, what's the measure of BC? 45 degrees. If BDC is the major arc, again, it's still a central angle. It's B to D to C. What's the measure of this big arc? 315. What if we have a semicircle? What if that's a diameter? This is 180 degrees, right? A straight line. And the arc is 180 degrees. Does it make sense when you put it together? If I take two semicircles, I get all 360 degrees. Okay, so we have this app called GeoGebra, and unfortunately, it doesn't measure arcs. Yes, I don't know if it's in the self-service store yet, but it's very nice. It is. Then you should download GeoGebra because it's a great app. But it doesn't work. I was trying to do something with circles, and it doesn't work very well with circles. It is also it's also a website. It's free. You can use your computer to do it. Okay, more words. More words. Oh, we're going to get there. Okay, shh, guys. A chord, now some of this is going to relate to calculus. A chord is a line segment whose endpoints are on the circle. So my chord here, there's one chord, dB, and it's a line segment, so guess what symbol I have to put above it? A line segment. Can the chord also be a diameter? I already talked about this. Yeah. And that's AC. The longest chord is going to be a diameter. Now, some of these words are going to come back, and you're going to see them again in calculus. If you're a ninth grader in geometry, your senior year, you should take AP Stats, AB Calc, or regular calc. One of those three. If you want to, yeah. If you want to go to Carleton or St. Olaf, and those are the only ones I know for a fact, they don't have anything lower than calculus. So if you take calculus here, it's to your advantage when you go to college.
My mom and dad went to Carlson. They say math is like murderously hard if you're not a math person there.
Yeah, I've taken classes there.
Take calculus.
No, because it's a circle. It just joins any 2 points on a circle. Okay, ready? These are the words you're going to see in calculus. Tangent. Now, tangent, that word comes from the Latin tangio, which means to touch. That's the E. Okay, Cole? And now a tangent is a line that touches a circle in only one point. So this is a tangent line. Well, what's going to happen in calculus is you will be looking at different functions like that, and you will be looking at the tangent line. Make the dot bigger. That's one of the things we're going to do in calculus. And some of you may take that. So it's related to the circle piece. So some of the vocabulary is the same. So my tangent line, this is AM. Now what should I put above it? I don't know, B. It's AM, and it's a line, so I better draw a line. What's the other tangent line? TH. Okay. Is that okay? Now, a secant, you're going to have to know all these words. Chords, the chord here is AB. Okay, TJ? That's a chord. The secant is the line. The secant is that whole thing right there. So the secant line is AB. Are we going to see this in calculus? Yes, we are. And we're going to expect you to know what a secant is. And by the way, the tangent has something to do also with the trigonometry. Okay, TJ? This is a secant line because it intersects my curve in 2 points. Okay, guys, Sydney and CJ. Hmm?
I've got a question.
A point, there's no tangent line here. A point of tangency would be just the point. Call it C. Point of tangency is the point where they touch. Just the points. Yes, so this is the point of tangency right here. Okay, so a secant contains a chord. Now, if you were doing math theme, I would like to get into a lot of theorems about circles and lengths of those chords and things, but I don't think we're going to be doing that in this class. Okay, let's do this quickly, and then we have one more thing to do. What's one radius? A radius, DE. That's a radius. There's a whole bunch of them. What's the diameter? There's only one listed. dB. What's one of the chords? DC. And also the diameter is a chord, so you could have either one of those there. Where's the tangent line? It has only, the tangent line only touches in one place. So it's FB. Where's the secant line, Cole? Secant. CD. It's any line that contains a chord and just goes beyond. We're going to do a lot of that in calculus. CD. No, it's tangent lines will lie outside your circles, but if I do a tangent line on a function, it could cross the function. Here's a secant line. Okay, do you see the secant? It intersects the circle in 2 places. So secants have 2. So it's CD. Can you name a central angle? Emmanuel, can you give me a central angle? DEA? Yes. Okay. AED is the same angle. You could also have angle AEB. Okay. What's a major arc? A major arc. D to B to where? This is a semicircle here. D to B to, that's got to go bigger than a semicircle to A. And then you have to put a little arc above there. Okay, TJ, so when you see the homework, you see the little arc symbol, you're going to know what that means.
Yep, I will.
TJ, what's a minor arc? DA works. What's the semicircle then? DCB or DAB. Okay. Are you okay with the vocabulary? It's not particularly exciting. Okay. Now, when you get to the last 3 problems, they're going to be like this one. So I'm going to trace this circle, and what this is doing, and you're going to do a lot of this in algebra next year, are translations. Okay, so pay attention so you know how to do this. This is going to take x and y, and it's going to take the x coordinate and subtract 1 from it. It's going to take the y coordinate and add 2. It's just going to move this circle someplace in the plane. If I move the circle, does it change size? No. So I'm going to get a congruent circle. So all you have to do is find the points. Let's take that point in particular. The x value is 0. The y value is 0. And this is going to take the x value and subtract 1. And it's going to take the y value, which is 0, and add 2. So this new point is going to be negative 1, 2. It's called a mapping. It's a transformation. It's what you do in the upper level math classes. So this x-coordinate is going to be moved to negative 1. The y is going to be at 2. Some of you may see it quickly. Some of you may not. But it's basically moving the whole circle over, isn't it? Let's take this point up here. That's at 2, 2. Where's the new point going to be? 2 take away 1 is going to give you what? 1. And then the y value, 2 plus 2 is 4. I know you're not. Neither am I. Chord is a segment that joins any 2 points on a circle. It should be in your notes. Okay, let's do this one. This is at 4, 0. Where is this one going to go? What is this doing to my graph? It's shifting it 1 unit to the left, and it's shifting it up 2 units, right? So that'll be at 3, 2. And let's do this last one, which is at 2, negative 2. This is going to shift it 1 to the left, so we'll subtract 1 and add 2. And if I draw that circle, are they congruent? Not bad for freehand. Yes. Okay, so when I transform something, shh, guys, and you're going to do a whole lot of this next year. Zach, please. When I translate something, I just move it. The shape doesn't change size. If I multiply by something, the shape changes size. We're just moving it. We're sliding it. That's all. Well, that's how you do those last 3 problems. I took the x-coordinates and subtracted 1. And the y-coordinate, I added 2.
So you did that for both?
For both coordinates. It's a different rule. You just have to follow the rule. This says take your x value and subtract 1. So I'm going to shift this 1 unit to the left, and I'm going to shift it up 2. It's easier for me to do the points. What's the tangent? Anybody know?
Yeah.
Oh,
Yeah.
But there aren't. Oh,
Now, let's look at number 12. We can look at number 11 too. I can draw it better than you guys can because I have tools. Number 12 says draw 2 circles that are congruent. Yes. Okay, guys, this is number 12. And then it says the center is at P. I'm going to slide that over a little bit. Cool. And this says centers at Q. Now, if they're congruent circles, what's true about their radii? They're the same. Then it says label where they intersect A, and we'll label that B. And then it says draw the segments joining these points. P to A. Oh, I didn't want to do that. I want it better than that. P to A to Q, Q to B, and P to P. Guys, I'm going to change the color so you can see it a little better. I can. The question is, what is this quadrilateral? Yeah, that's a rhombus, isn't it? Now, I have not done the homework. I need to do the homework, but I haven't done it yet. I think 13 is like the last ones. Number 9, that's a central angle. So how big is the minor arc?
no, number 9 on the homework.
Yeah, that's a central angle. The measure of the arc is equal to the measure of the central angle.
Oh, that's not me with minus 1.
Correct. 13.
Can you go back to 14, 15, and 16? Those are complicated.
Those, 14 is the one I did. Different place, I think. Just take the x coordinate, subtract 1, take the y coordinate, and add 2. No, it's exactly the one I did.
Can you do a little, like, swap?
Write down this ordered pair, 0, 0. And this is the rule. We're going to subtract 1 from this, and we're going to add 2 to that one. And that's this point right there. Just try 13. What's the 2 going to do? The 2 is going to multiply by the x coordinate. What's going to happen to your circle? Think about it. Write down the ordered pairs on 15, and then just do what the rule says. The rule says double your x's, double your y's. Okay. Oh,